Welcome to Pipeline Conversations, a machine learning podcast by ZenML. This week, we were lucky to get to speak to Noah Gift. He's one of the two co-authors of a new O'Reilly book called Practical MLOps, Operationalizing Machine Learning Models. We really enjoyed hearing about some of his own personal experiences. For example, his work to set up a sports social media startup. And we also got into the ways he sees AutoML as really being a significant game changer for data scientists. His book brings a great deal of hard-won practical experience to the table, especially for those early on in their careers. So let's get straight into the interview. You have this book, Practical MLOps. It's all about being able to, or making yourself able to get your models into production in all sorts of different ways and all sorts of different platforms and so on. And just to kind of set us up as the kind of context for this conversation, I guess, like I'd be interested in to hear your take on, like, what does production in ML actually mean? Yeah, how does that manifest itself?
Yeah, I could start with that. So most of my life has been around putting things in production in terms of my professional career. And I've done that in the film industry for quite some time. And that was actually a very good accidental beginning of my career for what's going on with MLOps in particular, because of the distributed file system and distributed computing aspects of film are accidentally very relevant to MLOps. And then a lot of my career when I was in the Bay Area was in a nutshell, if I had to describe it, was people made messes and I cleaned it up. And the way I cleaned it up wasn't like genius level things I was building. It was just doing things that people should have done in the first place, which is you have a checklist of the best practices and you walk through it and say, what is this organization doing? Are they doing these best practices? And every single organization that had problems didn't do the checklist. And the checklist is, do you have a build server? Every single failed project or troubled company, no, right? Like it's like you can't build software without automation. Like that's the heart and soul of things. So that's kind of my mindset of, a lot of the stuff that I saw personally, being successful at was executing things at a better level. Like really wasn't like a new idea or whatever. It's just let's tighten up the execution. So I see the same thing, because I accidentally got into teaching machine learning and data science and wasn't planning on anything. Just a professor asked me to do it. And I said, oh, okay, sure, let me try it out. And then I kind of like it. And so I've been doing a lot of it at different universities. And what I've seen as well is that in the data science world, there's a very surface level understanding of operations. And it's really a lot like almost like a child in a way where, I have a 2-year-old and the 2-year-old is just unaware of the consequences of his actions, right? Like he'll climb up on the couch and then it's like teetering on the brink of like falling. It's like, well, that's great that you can do this, but there are consequences for your actions. And so similarly, I think with a lot of data sciences, because of the culture of academics, is really to try out ideas, get research, and actually to be approved by other peers. And you see this as a criticism with Taleb, the person who wrote Black Swan, and kind of a caustic character. I'm not necessarily sure how fun it would be to hang out with him. He seems a little intense, but that doesn't mean he doesn't have some points that are valid. And like his point about academics being about people, having a peer review process where people have to like you, that isn't necessarily conducive to just that as it's the only thing you're doing to building things that work. Like they're not necessarily correlated. And so I think that's the problem with the academic mindset is that, hey, we built this model and look how smart I am. And again, that's great. That's great that you got that. But then now we need to make it work. And so a lot of the things that you don't care about now matter. So I think that's the real dilemma with machine learning and data science is that you have these two wildly different cultures Where in a DevOps culture, maybe you could even say it's too much towards making things work, and it's very like reductive, and Jenkins build servers and automation and every stuff. But then on the flip side, you have academics is like, who cares if it works? Like, I have this great idea. I had an idea, and it was my idea first, so I'm smart. And it's like, well, that can be good, sure. But ultimately, like Zillow is a great example of this. Like, does it actually make money, or does
Hmm.
it cure cancer, or does it solve a problem? And then the metrics are very different now. And so I think that's where there's a huge opportunity for MLOps, is that letting data scientists in particular know, like, that you need to be much more humble about the stuff you don't know, which is more 80% of the problem, which is monitoring, instrumentation, logging, reproducibility of your infrastructure. And that if you're not careful, you can get yourself in really big trouble and potentially make a fatal mistake to your career that you'll never be able to come back from. On the flip side, if you start with like a humble mindset and say, wow, there's all this stuff I don't know, and I need to very quickly acquire these new skills, that is a great attitude. And potentially someone could learn very quickly a lot of the DevOps type skills that they're missing if they're data scientists.
Yeah.
So that's my view of the world.
So that is like definitely an interesting angle also, because in our line of work we talk a lot to data scientists, so the actual producers of these machine learning models. And a common line of questioning that we've seen emerge is a discussion about roles and how they should be mobilized within machine learning based organizations. So, we have many roles that pop up in like job boards, like data engineers or ML engineers, MLOps engineers now. From the perspective of a data scientist, what do you think should be their responsibilities in an ideal setting, and where should the ideal handoffs be between these particular roles? Could you perhaps talk a bit about how, in your worldview, an ideal setup would look like, and perhaps we can go from there?
Yeah, I think this is an interesting topic, and there's not necessarily a perfect answer for it. But one thing I'll bring up is I was just reading the book Leonardo da Vinci by Walter Isaacson.
Yeah.
And what's fascinating about Leonardo da Vinci is that he was not really into having one skill. And so he had multiple skills. Like, he
Yeah.
was a sculptor, he was a painter, also was a scientist. He studied cadavers. Like, he throughout his whole life was dissecting cadavers to learn about the fundamental anatomy and physiology that he would need in order to develop realistic paintings.
Hmm.
And so I think that is really the ultimate ideal for a human being, is someone that is not really into titles or roles, like Leonardo da Vinci. Like, I mean, what was he like? What was he, a painter, or was he a scientist, or was he an engineer? He also built, helicopter prototypes and all these other things. I think that's really what a human is capable of at the highest level. So similarly with things like with machine learning and AI, I think it's very self-limiting to put roles into, like, well, this is not my job, or these are the things I can't do. I think it's very fixed mindset. Instead, I think someone should say that I want to produce a result that is amazing. So again, like the Mona Lisa, Leonardo da Vinci worked on it for his entire life. And every time he learned a new technique, he applied those techniques to the painting, and then died with the painting. Like, he
Yeah.
was never stopped working on things. So similarly, I think when someone is doing machine learning and production, like the kind of who does what, and like who gets this, I think that's in a way almost a bad framing of the problem. I think the framing of the problem should be, listen, we're working on this machine learning problem. Does it work? And if it doesn't work, how can we make it better? And how can I help? And what skills am I missing? So I need to get to the point, like, again, like Leonardo da Vinci wasn't like, wow, I need to find an anatomist, or, I need to find like someone who's an expert in the eye so that they can just paint this part for me. Like that didn't even make sense to him, because he wanted to discover it himself. So similarly, I think with data scientists should actually be more looking at their own model of themselves and see, like, where's my own model missing, and where do I need to go deeper on. And so if you need to know data engineering, then you should level up and you should learn some of the data engineering skills. Similarly, if you're missing on, operationalizing things, like, you should learn about infrastructure as code, monitoring, instrumentation. And then I think also choosing when to go deep and when to go shallow. So I think using platforms, I think, is another one that is a very common, or not using platforms is a common anti-pattern for academics, is like, oh, but no, I don't need that because I could do it myself. It's like, no, you can't do it yourself, because there are 1,000 people working on AWS SageMaker, for example, and you're one person. So you should build something on top of a framework that someone else has already built for you. So I think the data scientist, by using more effective leverage and also discovering where they're weak, that's the way I would frame the problem, versus the job titles and who does what, I think,
Hmm.
are very irrelevant to really getting the outcome.
Yeah, absolutely. I think this point is also illustrated well by Eric Colson from Stitch Fix, and he wrote a fantastic blog about how you should be aware of the data science pin factory, and how the power of the full stack data scientist is something that perhaps is necessary for many organizations. And in that blog, he illustrates it as an example from Adam Smith from The Wealth of Nations, where he talks about a pin factory and how, like, division of labor used to work with a pin factory assembly line, because one person can draw the wire, another straighten it, a third can cut it, a fourth can point it, etc. But in machine learning, there's so many causalities in the data, and so many feedback loops, that turns out to be pretty impossible. So you should perhaps be taking more ownership of the models. And I completely agree that you should just look at the bigger picture and try to see the gaps that you have. However, in relation to that, so perhaps we can then switch over to MLOps itself, right? MLOps is, of course, the framing of of a particular solution to that ownership problem, and like getting that model towards production. Should we perhaps talk a bit about levels of maturity of MLOps? Because another thing that a lot of people talk about is, when should I adopt MLOps, right? So a company who's just starting, a startup, perhaps a Jupyter notebook and a model deployment would be enough to get value or a seed round done or a series A done, or as opposed to, or perhaps a small company with different stakeholders, like, excuse me, a small department in a bigger company who has to convince stakeholders to move forward with a budget. When should, in the real world, teams start thinking about applying MLOps? Should it be that they should start with a full pipeline end to end at the start and take that overhead hit, because it's always going to result in a advantage at the end? Or should they iterate like you would in a machine learning model, also that pipeline and the whole MLOps system? Do you have any thoughts on that?
Yeah, I think, again, kind of going to the Leonardo da Vinci example, since I started with it, is that the way that he would create a painting was that he would first draw a sketch of the painting, and then, start to then apply the 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 new techniques to the oil, to the painting afterwards. So I think the same kind of concept is that it's best to get something working quickly, get an end-to-end prototype, and then evaluate the prototype and say, what is wrong here. And it, just because you're moving quick initially doesn't mean you're going to produce garbage at the end. You can move quickly to get, again, the sketch of what it is you're building, so that later you can improve it and use those best practices. So I think the end-to-end system working as quickly as possible is the ideal, but with the mindset that you're not building a bridge, you're actually nurturing an organic, material. So you're essentially creating, a plant or a tree, and that you're never done. right? That you can't walk away from some tomatoes. There will be bad consequences. There's every possible thing that could go wrong will go wrong. Squirrels, pests, lack of water, fertilizer, wind, hail, similar. So the idea is that you build something quickly with the mindset that on a daily basis you're improving the system and get more and more automation and more feedback loops and more quality.
Just to kind of ground the conversation, or to bring it down a bit from the theoretical, do you have any, I don't know, war stories from your personal experience, either successes of doing it this way or big catastrophes?
I think one of the first machine learning models that I built was when I was working for a sports social network, that we had a real problem, a business problem, which is we needed to grow our user base. And we also had very good relationships with huge celebrities like Conor McGregor, who at the time was very minor. Like, I don't know, he had like 10,000 followers on Twitter or something, or, like I have more followers on LinkedIn than he did when we met him. But we had other celebrities as well. And so the idea was, how do we figure out who to partner with and what to tell them to do to grow our platform? And so the first model we created, it was a long process to get it working, because in order to get the signals around who was successful in social media, we had to actually have proper data collection. And so I think this does, in a way, the problem will lend itself to what technique you should use. And so in this case, the first part of the problem was that we had to actually get accurate labeled data. And so for all the celebrities that we dealt with, we needed to figure out a way that we could capture birth dates, social media handles, accurate plane history. And so that took a while to develop, because especially at the time, there wasn't as much of these techniques available. So we built a mechanical Turk job that was able to, basically create labels for all the celebrities that we dealt with. We gave them just essentially a name and I think which team they played for in terms of sports, and then from there they were able to give us the rest of that data. But once we had that, that was great, because we solved a particular problem, but it was just the beginning of a more complex problem, which is, okay, now we need to go to those social media APIs and we need to collect their data, and we need to create a model based on that data. And so that itself presents all kinds of problems. Like, I need to, get around API limits. I need to control, the job failures. And so what I initially did was actually use off the shelf technologies that we already had. So again, a lot of these data engineering frameworks weren't around at that time, but I used just Jenkins, because Jenkins can just run things, right? Like, it's just run a job. So I would go to Jenkins, just said, okay, collect things from Twitter, collect things from, Wikipedia. And then we put those artifacts into storage so that we were able to have the data. So really it was like phase one, get labeled data, or no, actually phase one would be, what's the problem we're trying to solve? I mean, that if you don't have the business requirements down, and ours was pretty clear, like we have no users, we need lots of users. So how do we get more users? So we identified the problem. Phase two was actually figure out how to get the labeled data, which I would say 6 months probably took us to get that. And then three is, okay, create some kind of data engineering job. And then once you have that, then it was like, okay, let's start looking at, what features we have to correlate things. And that took maybe 6 months. Like, okay, let's look through, because your data, you have to clean it up, and you have to make sure it's ready to be doing feature engineering. And then once we were able to figure it out that the relative engagement on each post was a really strong signal that predicted users coming onto our platform, then what we did was, then I collected some other features, like how many people go to a Wikipedia page, things like this. We were able to create a reasonable first model using a very simple, regression based model. And so I used R, went through, created like a crude proximity. So it took, let's say, a year or so to create a full, end-to-end pipeline. Now and then now here's where some of the problems crop up that people are talking about in MLOps, which is that, one, we didn't have enough data yet to be able to create like a generalizable model. And so, there's a power law associated with celebrities. And so, creating just straight linear regression is okay, but it misses out on like it generally kind of it helps you predict what's happening, but a lot of the variation with the top celebrities aren't fit into a nonlinear model. And so we had to sort that out. That was one problem we figured out. And then there's also the feedback loop, which is now we got the model we put into production. And so what do we do when now it's live, and can we actually get feedback about the people that we're actually paying to do content posting? Like, how does that change the model? And so I think that's really the story. I think with MLOps is that you have to start with a business problem and then break each piece down and solve it. And that if you get too far ahead with building the ultimate platform, you never would solve the problem. And you have to be okay with things being a little bit dirty and messy at the beginning, so that you can actually get to the point where you know what it is you don't know yet, and then you can improve it. So that's been my experience of the process with MLOps.
That sounds a little bit like these kind of best practices that you were talking about earlier on. Like, do you think in the MLOps world we've converged on a series of like agreed best practices yet, or do you think that's still in kind of influx a bit?
Yeah, I think there's 80% I think are probably agreed on. So like, for example, if you don't have DevOps, capabilities in your organization, you're just dreaming if you think you can do machine learning at scale. Like, how could you possibly do this? It's not going to work. Like you have to have the ability to deploy your model into production without people being involved and clicking buttons. You might get it right a couple times, but eventually you'll have a catastrophic failure because humans are spinning up the wrong servers and making mistakes, and there's too much complexity for machine learning. I mean, because you could almost get away with not doing DevOps for a little bit with software, but you have all this additional complexity with data flow and machine learning. So I think that's definitely, I would be surprised if anyone says you don't need DevOps that knows what they're doing. I mean, that would be a grossly irresponsible thing. Then the second one is kind of what I was talking about before, is I think you need to have some automation involved with data. It's almost impossible to do any machine learning system if you don't have some form of automation for your data. It's not the case in the real world that the data is static and you just go to Kaggle and you download it. I mean, that's just not what happens. The data is a dynamic component of your architecture. So I think those are two very strong patterns. And I would say probably a third one would be, again, the higher level tool you can use, the better, because there's like, you take AWS SageMaker, not that I'm necessarily in love with AWS SageMaker, but just as a common frame of reference, that it's orchestrating all these things like training nodes, endpoint scaling, working with elastic storage system. Like, do you really want to write all that? I mean, come on. I mean, who wants to build all that stuff yourself? Why don't you just use a system that can handle the orchestration of training jobs, orchestration of endpoints, orchestration of disk IO, right? And flip side is, let's say you did do that and your company's the geniuses, they build all that stuff out. Good luck training the person that comes in that just got a master's in data science about your bespoke platform that they've never heard of, that works in a very bespoke way. Like, so I think I would say those are three that seem pretty clear: is use some kind of platform, have some kind of form of data engineering, and then also have DevOps. Now, there are some other things I think that are emerging that will be very interesting. Like, when should you use transfer learning? What about the feedback loop of once the model's in production? How do you actually accurately respond to the predictions and then apply those results back to your model? I think that seems a little more of a dynamic area, but that's, I would say, the 20% factor.
Yeah. Yeah, I was actually going to ask you about that. It's cool that we arrive at this point organically. In the space that we're in as well at ZenML, we're talking. So there's an explosion of MLOps tooling right now, And a lot of them seem to be overlapping in the areas, but there seems to be a picture forming of different abstractions and typical patterns that emerge in an MLOps platform that you described. And you have a chapter in the book which I found interesting about interoperability. And in that chapter, you focus a lot on the Onyx model and how you can transfer it's just like a standard format for those who know to store machine learning models. Is there other patterns on different levels of the pipeline, for instance testing or drift detection or monitoring or orchestration or any of the things like metadata storage or artifact storage? Do you see any other typical patterns emerging where you think interoperability and standardization could be valuable for the industry, or do you think that that should be a bespoke thing for every company individually?
Yeah, I mean, I think that in general with software, it works better when things are standardized and simple. And I think containers are one of the areas that will be a standard. It seems like at this point, it's almost impossible to avoid containers. Like you can't like not use a container. So they're going to be either the thing that your microservice is using or your ML algorithm is using or your framework is using. So I think that could really go a long way as having like very good automation around containers and versioning of the containers for all the components of your MLOps pipeline. Another one I think that's a very interesting emerging trend here, and this kind of goes back to what I said earlier with film, is that it does appear that because containers are so important to machine learning, that potentially the distributed file system is going to make a comeback. Because one of the things about Kubernetes is it's true, it's very powerful, but it's also very complex. And I think there's a chicken and egg problem with Kubernetes. It's like, okay, great, we have Kubernetes, but okay, but who's running Kubernetes, right? And what's underneath the hood of Kubernetes? You can't just wish that complexity away. Like, oh, we don't have, we need more compute, we need more disk I/O. Like, so this is where I think the distributed file system is very interesting because you could potentially have these containers living on a distributed file system. You could have the Kubernetes system be, kind of interacting with that. You could have the models living on the distributed file system. So the cloud storage by itself is, the object-based storage is okay, but in a way it's kind of an older model in some sense. Like the Hadoop model of like spinning up huge virtual machines that like takes 10 minutes for each of them to launch, and then they pull data from object storage, and like, I mean, that's a clunky workflow. And I think that if everything's on disk and it's also a lighter weight virtualization, I think things are getting much more interesting, and it's a lot easier to do things like the feedback loop of production prediction. So if you wanted to have real time model training, for example, in response to how your model is deployed into prediction, like, you deploy a model that helps people buy products or whatever, and then you have four cohorts of people you're monitoring, and then you wanted in real time the model to retrain and apply four different models or something like this. Yeah, okay, tell me how that's going to work with like 10-minute virtual machine launches and like moving data back and forth from S3. And like, I mean, that's like a very heavy, I would call it legacy type workflow. But what I think is very interesting is that if you say, hey, I want like millisecond response time, that then I think things get a lot more clear in terms of being able to optimize machine learning feedback loops. And so I think there's something happening here that will probably shake out
Mhm.
in 2022.
Interesting. Do you have perhaps a tool or a set of tools in mind that facilitate that? Is that like a project that you see active that would help with what you just described?
Well, I think like, for example, Amazon has two different distributed file systems. They have EFS and FSX. I think FSX is the NetApp one. I think, for example, if everybody has the mount points on their machines and everything lives on disk, then your build server can build containers and push them somewhere where they're easily launched the models are living on disk and they're easily launched. So I think it's the combination of a high level platform that also has access to a mount point using something where again it's all managed for you. So like if the Kubernetes cluster is managed for you and the file system is managed for you, then you have build servers that automatically push all of the raw components, models, containers, all this stuff. Then you have all of the ingredients to build very very advanced real time machine learning systems.
So, so I'm going to inject the early career data scientist back into the conversation a bit. So, I mean, you've been engaging in teaching people for quite a while, I believe. Are there any kind of usual paths you see for someone coming into this world from data science into having more involvement in productionizing things? Like, do you find people specialize a lot, or are they kind of encouraged or have to kind of work across the whole stack?
Well, so far, what I've noticed is that when I'm teaching students, I teach really two cohorts. I teach either graduate students who are typically, I would say 22 to 26, and then I also teach working professionals who are getting a master's degree. And in general, what I've noticed is that the students get very little software engineering real world experience. And so in the classes I teach, they're building microservices, they're building serverless, data engineering systems, and then they're building multiple projects and demoing those projects on a weekly basis to ultimately build a series of individual projects for a portfolio. So I think that's the best advice I would give anybody, is that you need to practice building systems, and you need to demo building those systems like every single week, because that's how a real job works. Like if you're at a startup, I mean, if you want to figure out how a startup's going to fail, it's pretty simple. Like, do you demo every week? My opinion. If you don't, you're screwed. I mean, basically, I mean, right? Like, how can you possibly be a startup and not incrementally improve your product each week? Like, it's just you can't. Similarly, if you're trying to learn, operations components in the classroom, you need to demo every week, And what I've discovered is that it's a very effective way to teach MLOps. And so I think data scientists that are not doing that need to immediately start doing that. Is start building microservices, building small systems, and just every week make it a little bit better.
So, like, perhaps we can then also build on that. And I know that you talk a lot about AutoML in your book, and obviously that's perhaps something that you're also teaching. We already talked about how a data scientist should take ownership and perhaps fill in the gaps of their knowledge base. If they're missing data engineering, they should pick up those skills, or ops, or something along those lines. From what I understood from your book, your prediction is that AutoML essentially would take over the industry in the next 5 to 10 years, and the job which we're not talking about is a data scientist would be automated completely. Is that one of the reasons that you're encouraging like these data scientists to move towards a more end-to-end spectrum, because you see that as a natural consequence of what's going to happen in the industry, or is there also other motivators for that?
Yeah, I would say I don't know if I would say it's necessarily 100% replacement, but I would say a lot of replacement for data science. Because if you look at, again, I think Kaggle is a great example of something to throw a rock at, that it just doesn't make sense to me. Like the whole concept of Kaggle, like because if the goal of Kaggle is to teach people how to do data science from like like a more of a like a an academic standpoint, yeah, okay, there's some good there. It's like, again, I have a 14-year-old son, and he is doing math and writing symbolic notation and equations and all that stuff, and it's good to learn all these kind of classroom type things. The problem is that you don't go to the grocery store and on a piece of cardboard or like a grocery bag start writing out like symbolic notation and start like figuring out like all of these equations to buy oranges. Like you're doing very simple math in your head to solve a problem. And so similarly, I think with the data science, that it would be naive to think that all of a sudden when automation starts, that it will fail. Like, just give me an example in the last 500 years where someone started to automate something and then it failed. There obviously there'll be exceptions to the rule, but like, there'll be examples of someone trying to automate something and then ultimately the automation didn't work. But in general, once that starts to happen, it gets complete. And so what I think will happen is that the jobs that people used to do, like the elevator operator, like, well, I mean, why would someone do that? Like, it doesn't make sense. Similarly, with some of the components of what you do on Kaggle are just, in my opinion, just nonsense. Like, why are you picking what hyperparameter a k-means cluster needs? Like, how is that helpful? It's like there's zero help involved in, like, we need 4 clusters. No, we need 5. Like, I mean, why don't you just have a bunch of automation that tries a bunch of ideas out and gives you a dashboard and you look at it? Now, I don't necessarily think that means that everything goes away, but I do think that maybe 80% go away, and then they have to do a different role. Where, if you look at the medicine, medical industry, for example, you still need domain experts. I mean, you need like an orthopedic surgeon to look at an ankle or elbow or something, and they have deep experience with looking at CAT scans and looking at what's happening, and they've read all the medical research. But they're much more effective than just like, hey, let's open up your ankle and just start playing around with a knife and just see what happens. Like, that's not fun. Like, I don't think most people would want to like have someone do experimental surgery on them if the expert could use all these advanced automated tools that can let them be extremely effective. So I think it's just data scientists that potentially it'll be morphed into a domain expert, where potentially all domain experts will have the capabilities of data science. So I think a doctor would, I wouldn't say would, it would say all doctors, they have the math already training. They should be doing data science inside of what they're already doing.
Hmm.
I think it would be ridiculous to have like some, academic data scientists work with an orthopedic surgeon and like, yeah, let me look at your data for you. And it's a bad workflow. So it'll just be embedded inside of the domain expert. So yeah, I think if you think as a data scientist that your job is safe if you're going to be doing the things you're doing on Kaggle, I think it's very naive. And so it would be a good idea to get 2 things. One, better software engineering skills, and then B, better domain expertise. If you have both of those, I think you're going to be in a great position to leverage MLOps. If you think you're going to be doing Kaggle better than other people, I think you're going to be in for a rude surprise.
Is there kind of a prediction baked into that around kind of this MLOps space, around kind of just like heavy consolidation and so on? Is that kind of where you're going with that?
Yeah, I think many organizations are going to look like there's all these trends that are happening. It's hard. I mean, I don't know if I can predict completely the future, but let's look at some of the trends that are happening. We have COVID-19 has just completely disrupted the workforce, and now workers have all this power. And a lot of people know that they're more productive when they're not in office. And so for example, you can't just throw bodies at a problem anymore. So what's going to happen is that a lot of automation is going to take place in terms of the software industry, because you just can't hire people. So if you can't hire people, why would you just keep trying a strategy that's failing? So that in itself is going to accelerate the automation that's already occurring in terms of data science. So I think then on the flip side, there are going to be organizations to start to look at what they're spending on data science, and if they're not getting ROI, why would you hire all these people that are very expensive that you can't hire anyway when you're not getting the ROI? So I think there will be consolidation of data science, which again, I think it's going to go in the bimodal. It's going to have, you're going to look for people that have strong full stack skills and also strong domain expertise, because they're just extremely valuable. I mean, just imagine like how valuable like an orthopedic surgeon who is an expert at data science and knows how to deploy models into production. Like, I mean, that's like, the dream
Unicorn?
scenario. right? So that's what I think is that I think that there will be acceleration of the bespoke, the kind of the bespoke academic data scientist. It may go away quickly. It may go very quickly, but be replaced by you potentially people who are really, really productive experts in a particular field who have more Leonardo da Vinci type skills.
Awesome. Cool. So, all the listeners beware who are data scientists, perhaps take a look at what's going on around in the tooling landscape and how it works in production. I think that, like Noah, you talk a lot about the big cloud providers, right? So the SageMakers of the world as a good early path into that, into understanding that world. Do you still think that's the case, or do you have any other suggestions for our listeners who might be data scientists, or do you just suggest them to do a certification or something to start off?
Yeah, I think both. I mean, I think that a good way to start off is get certified on a cloud provider. I'm not necessarily saying you should pick one over the other, but from just a data science perspective, who's got the biggest market share? It's AWS, right? So that's probably the one that's going to be the most impactful. Get that certification. I do think it's a good starting point to use whatever platform that cloud provider is using. If you get certified with Microsoft Azure, then you should probably use the Azure ML Studio platform. And the reason for this is that they just the scale, right? It's basic microeconomics. That doesn't preclude you from later using third-party tools or enhancements to the platform. But I think one thing that especially companies in the MLOps space have to be very, very careful of if they want to compete is look at the user of the cloud platform, that they're most likely not just doing MLOps. They're most likely doing other things in the cloud. And so you have to play nice with the cloud provider. Like if it's like, hey, I'm building some things that are better than AWS Lambda, it's like, no, you're not, right? Like
Hmm.
people are already using AWS Lambda and they do event-based processing and they have all this tooling and they have all this stuff. So it's got to be an enhancement potentially on top of what someone is already doing inside of a cloud platform. And so that's why I do think for data scientists, if they have strong expertise in cloud computing and they have experience with whatever cloud they're on, ML platform, it's a great foundation to be reactive to whatever comes next, which we don't exactly know everything that's going to happen next.
I feel like a lot of the pain points around these, like I would call them general, like catch-all platforms like SageMaker, and they, of course, they are the most popular, but they haven't taken off yet, right? It's not like this, the standard, is that because they're so general and so awesome in what they do, but perhaps too general, it doesn't necessarily translate to every use case. And because data science is so, let's say, so much more complex than conventional software engineering, you can't just standardize it on a platform like Kubernetes, for example. So people find it hard to fit into the workflows that are predefined by Amazon or Azure or GCP. And a lot of what we see happening is they're building their own internal platforms that abstract away common patterns that happen within, which are specific for their use case. Do you see if that's a trend, you see that everyone builds on top of these platforms and creates their specific MLOps platforms, or do you still stick to the opinion that yeah, everybody's going to be on SageMaker and adapt their workflows to them?
Yeah, I think building on top of a platform does seem to be a trend. Like I know some people at a autonomous vehicle startup that they're doing that. Like they're building a bunch of stuff on top of SageMaker. It seems like a good place to start, right? Like I agree. Like that's the thing about AWS. Like if you take AWS in particular, it's building blocks. It's not a gourmet meal. Like if you go to Costco, you can get like huge, like 50 pounds of like, ribeye steak or something,
Wagyu.
but it's not the gourmet meal. Like you have to go home, you have to slice up the steak, you have to season it, like put it on the grill, all this stuff. Similar, like with AWS, it's low level things. So some of the things are great, but it may not be exact fit for everything you do, and that's why I think there is an opportunity for third party MLOps companies to enhance. Like a pain point I think for SageMaker is that it's just slow. Like this idea that again you launch virtual machines for everything is, I don't know if they're going to fix this. I would guess they would at some point, but there already are open source tools. Like there's one that I'm familiar with called ML Run. I don't know if you're familiar with it,
Yeah.
where like just you launch you launch Jupyter notebooks in like 10 milliseconds. Like why would you not want that? Like you just go through and you launch things very quickly. So I think it's probably going to be an 80-20, where like a lot of stuff you can use SageMaker, but then there's a 20% that's like, this doesn't really fit that perfect, and we need to build some stuff on top of it. And then that could be the opportunity for startups, I think, in the MLOps space, is that if someone's building some stuff that's bespoke on top, and if you have a better solution, I think the smarter companies will say, okay, let's go with this other solution that someone else built for us, because we don't want to build frameworks. I mean, that's a bad idea for companies that are trying
Yeah.
to solve business problems and make revenue, to build things that have nothing to do with their company.
So yeah, we have two final questions. You're our first guest, so I can't say we ask all of our guests this, but as of now, we will ask our guests a couple of questions just to close out. First off, what would you say would be a quick win that someone can add into what they're doing to make their productionizing of their models more robust?
I would say look for things that aren't automated and make sure they're automated.
And what would be one part of putting a model in production that you think should be given a bit more attention by tool makers in the MLOps space? Is there anything that you see as being neglected?
I think speed and simplicity are two things that are just not really covered right now in machine learning. I think, again, the virtual machine based launch story is a bad story. So make things faster and simpler.
Okay. Well, yeah, thank you so much for taking the time to talk to us. It was a real pleasure to get to speak to you. And yeah, we spent the last few days head deep in your book, and have been really enjoying it. And I'm glad to see that other people are reading it. Yeah, the kind of ideas are getting out there, helping people getting into this space. Thank you for listening to this latest episode of Pipeline Conversations. If you enjoyed what you heard, please consider giving us a review wherever you get your podcasts. It helps us get seen by more people, and of course, it's always nice to receive feedback. If you have suggestions for future guests, please send them over to podcast@zenml.io. Thanks. Until next time.